Hello, and welcome back to the next part of this Griscom and land cover change analysis using modus and dynamic world data. I believe this is part 9 of this video series. And in this video, what we did last time was we kind of set ourselves up in a position to be able to run this notebook and compute all the stats that we need going into a page like this. And we're building one of those for Indonesia and Mozambique, and also some appendices. So maybe let's create some room for the appendix here. Uh, there seems to be a last slide. Do I really need this? Nope. Seems like a reference that's not relevant at this point. All right. Great. So we have enough page real estate, and we're in a position to start executing this. I'm just thinking out loud. Do I need to do anything else? Nope. I have already set up the folder structure here for the output files to go in, and I've set up the input shape files here. So I'm in a good place. And we can start estimating that. Okay, so before I run this, I'll just restart the kernel and clear all the outputs. I know that I'm in an environment that has all these libraries. This should work properly. Let's confirm that. Okay, it's run. Brilliant. Loaded all the shapes now into my list. That works fine as well. Now I'm going to start generating the modus land cover files for all of these shapes. I notice I have not set up one thing. I also wanted to calculate this at the entire aggregate level, and I call that file, if I remember right, 16,000 underscore hectares with a capital H. And I'm going to call this 16KH8, the same EPSG code convention. So I'll just refresh that list so now it has that file as well. And let's go run this. This is going to start putting a bunch of files into the output folder, and it's going to put 11 files for each of these 5 shapes. So it's going to put 55 files into that folder, and each of these is going to be a capture from modus, and it's going to add up all of the total land cover percentages, and it's going to put it in there, right? So that's the work it's doing in the background. So let's run this, working on Mozambique, and it's asking me to just authorize this as an eligible Google Earth Engine app. So when I click this, it hasn't been verified as an app. All I need to then go is, yes, I allow to do these. Fine for that. And then it gives me a token here, which I need to just come in here and put that in. And once I do, it will start running. So now that it's going to run for a while, I can talk through what that token exactly was. So in order to get data sets, and specifically data sets for these regions of interest from Google Earth Engine, I could either perform that using Google Earth Engine's own JavaScript browser code editor, or I could use a library for Python that then interfaces and accesses Google Earth Engine and gets that data source, and then I kind of provide all the instructions to Google Earth Engine's cloud compute platform, but through a Python interface. The Python interface I'm using is called GEE map. Let me show you what that is. So I don't need that anymore because I put in the key, but this is the package that I use, gmap, and it's built by a guy called Dr. Chu Sheng Wu. And so this is the package I use, and in order for this package to connect with Google Earth Engine and verify it, what I'm building here needs to be verified as an app, which means I need to go to Google Earth Engine, generate a developer token and put that token into this. Only then will that interface complete itself. So it's doing that. So basically, now that I put it in, it's running the work it needs to do. So look at what it's doing. It's just been saving each of these 10 files. So it did the 10 files properly for Mozambique, and somewhere in the middle it failed for Indonesia, right? Request payload exceeds the limit size. And this is going to be probably uniquely a problem for Indonesia, is it? Add layer ROI name NAS. There's no reason why this should generate an error. It's only doing so for Indonesia, right? So I'm going to try this again. So I'm going to start from the first element of this data set. Let's try again. Right? I think it should run properly this time, but if not, we'll take some contingency steps. We'll see what we do. We'll see if we can simplify that polygon in some way. Could be such a complicated polygon that it needs to do very different kinds of data extraction and stitching. And Indonesia's coastlines are surprisingly big, so it could be a case where it's trying to retrieve too much information, and I need a paid gateway to access that. Let's see if we can succeed at this for some of the other forests. If not, I'm gonna have to create contingency plans when I either coalesce these polygons in some kind of meaningful way. I dissolve it, or I kind of have to draw out a simpler polygon. Things like that. So we're getting the same problem here for Subanjariji as well. Martapura. Let's see how this is working. But we should be able to confirm that if I refresh this. Come on. Sorry. Entirely wrong file. If I refresh this, I should be in a position to see those 10 other files saved. I don't see them, so it is doing the work for Martapura, and it's saving to some absurd location. So I definitely need to change where it's doing the saving, right? So, and I want to see where that file path is. Okay, it's not in this, it's not here. So it's going to have to be inside futures utils. There it is. And that's not where we want it. We just want it to be here. Right. So it's doing the work for Martapura, clearly. So we have a problem with the first two polygons, and we're going to have to simplify it. We'll get there. So it has put its work into some folder. We'll just run it again to get this data. But I'll just save this file, but it won't work until I actually restart the kernel. So we'll just wait for this to complete and do that. And rerun this for Martapura and Mozambique. Clearly, it's not a function of the total area because Mozambique had 151 kilohectares, while Subanjariji only has something like 8 kilohectares. So I'm really wondering, it's not a linear mapping, it's really related to the complexity of the polygons and the number of clips that clip to shape operations that one is trying to execute on Google Earth Engine and then stitch together all that generated data. I think that's the That's where the problem is, and I think drawing simpler boundary polygons is going to solve this. So while it's still crunching things meaningfully for Martapura, I'm just going to retain it that way, and let's see if it does the work for 16 kilohectares. I think it'll fail because if it has failed for Subanjariji and Benakat, it will probably fail for this. I would be very surprised if this works. You could also try repairing the polygons for Benakat and Subanjariji by doing a 0 meter buffering. Uh, if that works, that's good. Yeah, it's taking absurdly long, so I would expect it to fail any point now. Anyway, this is where it had copied the files, and I do still need it, so I'm just gonna copy while I just change the file path, and I'll use that later. For now, I will just bring all these files in so we have them. Sorry. All right, let's go back to see. Absolutely. So it's failed for this as well. So we expected. So that's great. We just need to now go ahead and fix those two polygons for Banakat and Sabanjariji. Let's do that. All right. Yep. We need to fix these shape files in some manner. The first thing I want to experiment with is in QGIS to kind of see if this was about polygon repair. So let's try repairing it first. If that's a problem, then we'll draw simplified polygons. All right, new project. Let's bring in the GCS shapefile. Interesting, it's been generating its own shapefiles for some reason. Oh, let's not worry about that. Not sure why it's saved it as a new document, but that's fine. I just need to take Banaka, and I've brought this in here. You see how complicated a polygon it is, and it's truly not just built for simple operations like this. There's so many tiny polygons stitched together, and these are frighteningly large, like some of these, because of the amount, the length it has to estimate. It's like a fjorded coast, so it's pretty difficult. But the first operation I want to do is to generate a buffer. We have only the one layer here. I'm going to create a 0 meter buffer. I'll run it. Great, I have this buffered polygon which is exactly the same, and I'm going to save these features as a shape file, and I'm going to call it exactly that. Save it, replace it. Yeah, so finally I've generated a new buffer Benakat polygon. This is the one that we need to work with, and just to check if this succeeded now, let's return to Python. Let's try what this does now for Benakat. But before I do that, I'm going to just restart the kernel and clear outputs. This would also have fixed the output path where these files get deposited in. So it'll no longer write to a folder that I don't recognize. I'll only write to the folder I want it to. So now we're gonna try this again for Banaka. See if this succeeds. If not, we need a much simpler polygon. Without all of that fjorded coastlines to worry about. You must be thinking, how do we then estimate it if Griscom potential is causing this problem and also we're running with some simplified polygons on this? How are we actually going to estimate it for these two? The answer is you have some reasonably high resolution drone imagery, and we can use other methods to estimate it at a field by field or plot by plot level and then aggregate it. So and that should be done programmatically. Anyway, so we failed at that. We're just going to have to create a much more simplified polygon for this, and I'm going to start trying to do that now. So the majority of our area is here and here, right? And I'm just going to sketch around that. So let's get rid of these two layers which we don't need anymore, and let's create a new temporary scratch layer in QGIS. Call this Banaka simplified, and the geometry type is some multi-polygon because I want to have multiple polygons in there. EPSG WGS84. We don't need to create any other fields except for the geometry. Also makes it much more lightweight. But we can, now that we're in the edit mode, we can already start drawing now. So my simplified polygon is going to just look something like this. Look what I'm doing. I'm just taking the most important parts of this forest here and making a polygon so we don't miss out on where the majority area is. So I made one polygon like that. Tributaries, we're gonna just skip that. I know there's gonna be potential there, but we're gonna make a estimate to skip that. So remember, this is a multi-polygon layer, so I can actually draw multiple polygons. So you skip that. Let's take some of this area here. Once you get good at drawing this, it becomes quite easy. Right. I believe I haven't missed much area there. Where else do we have some potential? I think there's some here that I don't want to miss. Like I said, Indonesia's coastlines, just the way they're situated with the curvature of the earth, and you see them on most maps. They look really small, but the areas are quite large. That's why Indonesia's coastline is second to Canada's. So I don't want to miss that area for sure. And also, I don't want to miss some area here. Right. All right. I think with that, we've kind of left out some of these tributary areas, but I think I can live with this simplified polygon. So I'm gonna go ahead and export this, saves features as an SC shape file of its own, and I'll save it in the same folder as Banaka simplified. I want to make sure that I'm in the correct folder, right? downloads, land use, land cover, shapes. This is where I want to save it. Yep. Then I got simplified. Better still, save it as BNK. Okay, great. So we have the BNK polygon. So let's take all of this out. Let's solve for the SBJ polygon. Right. Here, I just brought in Subanjariji. This is simple. You only have two real big clusters of large area places. So once again, let's just create a temporary scratch layer. Let's call this Subanjariji simplified. Geometry type is multi-polygon. Okay, and let's just do this really fast. Let's draw that polygon pretty quickly. Right, we've drawn one, and now let's draw the other one. You don't need to worry if your polygon has, I don't know, you click like 20-30 times. I think it's pretty normal to have for a polygon to have that many interfaces. I think this is all I really want to capture for Subanjariji. I wonder if I've missed some areas on the top. Gosh, alright, let's go and capture that as well. Should have made a better polygon of that. Alright, 3 polygons for Subanjariji. Better still, I'm going to select these two, and I'm going to do some kind of vector geoprocessing dissolve operation. I don't know. Interesting. Layers. They need to be separate layers. Okay, you know something that's not very important. We're just going to look at it as an aggregate within the 3 clusters. So I'm not going to be too worried about this. So I'm just going to still preserve this. Just going to click out of this. So we have this. I'm just going to export this as a new layer of its own. And I'm going to do that in this entire shape area here. And I will save it as SBJ. Okay, great. So now we have SBJ, we have BNK, and we have Martapura here, which if you see does not seem to have so many tributaries, which is why it processed easily and meaningfully. And see, Google Earth Engine can handle so much complexity. I'm just going to go and save the sum total of all these 3 layers. And now I'm going to start merging these layers into one. So I'm going to use vector operations, geoprocessing tools, and dissolve. I'm going to use dissolve fields. Nope. I'm going to use union. Great. So Marta Pura overlaid with P and K. Union create a temporary layer. Run. Failed. Okay, P and K seems to have an invalid geometry. What did I do wrong? Okay, let's solve for this in the next video. We've created simple polygons here, and we know we're going to succeed with those. I'll fix the PNK and SPJ polygons, merge them together to form a 16 kilohectare polygon, and then let's run that through Google Earth Engine to get